Well, I don't know if this is working, but we're gonna try it out. I'm trying this whole live stream thing, and we're gonna see if it works. I have no idea what's gonna happen, but if this works, this will be awesome. Because this will let me get videos out to you a lot quicker than recording them, remuxing them, uploading them to YouTube, waiting for them to get converted. It takes a few hours, so this hopefully will work out a little bit better. So what we've got here for you today is part 2 of the magnetic scoop tutorial. We have a vessel that is pretty simple. I tried a lot of different configurations and whatnot, but really the best way to go about building this vessel was just to keep it as simple as possible. So here's what we've got on it, and at the end here we'll definitely jump into the VAB, and I'll show you this in the VAB because the light's kind of dim out here, seeing as how the nearest sun is a gazillion miles away or something like that. So what we've got, we have the Muon Catalyzed Fusion Reactor. That's down here. That's providing us with power. Currently we're using neon alpha just because we're in rest mode, so we're not actually doing a whole lot. Just collecting solar wind, not processing it, because we're quite a ways between, but this is a particular point where we actually start collecting solar wind from the star that we're heading to, which is Dawn, from the World Beyond pack. See, way up there we've got we got Traverse inside its little nebula. That's super awesome that we have a nebula there. We've got Dawn behind that maneuver or that encounter node there, and a few other stars. So we're actually pointing towards quite a few celestial objects. So we got Dawn, that's one star, that's the one pointed directly at. Over here we've got, behind Dawn there's going to be Oblivion, and then you're going to have Aeon and Barrier, like somewhere over in this general area, and then over here you got Traverse and Fragment and Ascension and Eternal. So you got like 4 stars here, and then 2 over here, and then 2 over here, and you pretty much are actually able to collect from all of them once you get close enough. So the point that we were at there, sorry if takes a minute because I have so many visual mods installed. It takes a minute to go between map and live view, but we're not very far from Kerbal, from the Kerbal system. We've been in space 245 days. We flew around the sun, just kind of left Kerbin, went into a lower orbit around the sun that just kind of slingshot us straight out of the system. Probably not the most efficient maneuver, probably not the most scientific or mathy maneuver, but I wanted to get going out of the system really fast so I can make this video, so that's what I did. And we are cruising along at 500,000 meters per second towards Dawn, and we're still not going to get there for another 214 days for the encounter. And going to be in space for like 450-60 days, but still a little over a year to get to another star, traveling at less than light speed. That's pretty cool. So I didn't realize that these things were so close together, so it's actually a lot easier to get to them than I thought, but it does still take a lot of time. So let's show you how we do this. Okay, at this altitude we got our magnetic scoop right here. Down here you can see we're not using ionization, and I've got the magnetic field really low, because we're not actually processing anything. I'm using neon right now because I don't use neon for anything else, and there's plenty of it in the interstellar medium to use this thing on low power mode. I can't actually run the refineries and things like that consistently because there's just not enough power. If I turn the scoop all the way up, we start losing power because the reactor can't actually keep up. So we're going to turn that down. And actually we're going to go ahead and just switch real quick. So proton deuterium gives us a lot of power. The CNO cycle, anything that gives us a decent amount of megawatts is going to work. Proton, triple alpha is a good choice. And that just uses helium, which again we're collecting in abundance and don't have any other use for. So for this particular phase, when we start switching on some of our tools, I'm going to use helium as our reactant because there's plenty of it and it's free. So we go there and we switch to helium. We move over here and we move our magnetic field back up, and actually power management, Yeah, I guess we actually don't have quite enough to do it with the helium. Proton deuterium's a little overkill. We'll do the CNO cycle. We've got lots of hydrogen. I know we're using the hydrogen as our fuel, but we're already moving pretty quick. And it fills up super fast. Let me show you how fast this fills up. Let's see here. So we got that on. Oh yeah, take a look at ionization here. It really doesn't work out here in interstellar space. So if I turn on the refinery, where's the refinery? That's not a refinery, that's a refinery. Turn on the refinery, turn on solar wind processing, check our power usage. Yep, we're still in the green. Okay, 34 grams per hour. That's a lot of hydrogen. That's a lot. It's tons. We're also getting 12 grams of helium, so, you know, a lot of fusion fuel to keep the batteries, or to keep the lights on. Actually, I didn't put lights on this, I should have. Deuterium and helium-3, there's not that much helium-3. I tried this with a tri-alpha using helium-3, and it ran out of fuel in a couple of days. There's just not enough helium-3. I'd have to have, you know, a planet-sized collector or something like that to run the tri-alpha, but that's okay. Oh yeah, the Bussard engine's down here. Runs on, you know, solid hydrogen. It's got its own refrigerator, so you can do that, but I've got a refrigerator unit on here, so I'm already just keeping the hydrogen in liquid and solid form instead of gaseous form. That way it, you know, just fills up on solid for the fuel and then stores the rest as liquid. It works. Don't actually have a use for the monopropellant. Forgot to take it off, but that's okay. Deuterium, hydrogen, neon, that sort of thing. We're just keeping the neon in this tank so I didn't have to put an extra fuel tank. And then all the hydrogen goes in these guys. Oh, not in that. Sorry. Let me move this up. Goes in these guys, the little cryogenic tanks. They're great. I got a bunch of them on there, and you can basically fill all of them up in like a day, just traveling out of the Kerbal system. So I fired my engines in, you know, near the sun, and then I turned them off, and then I pointed the scoop at the sun, turned off all other systems, and just collected, you know, hydrogen to fill my tank back up as I exited the system. And then once my tanks were full, pointed it at dawn, and fired until I ran out of fuel completely. And then turned the scoop back on, pointed at dawn, waited till I could collect, you know, more hydrogen, filled my fuel tanks back up, and I'm ready to fire again. And I'm still, you know, I'm going 500,000 meters per second. You know, 477, you know, kilometers per second is, you know, moving pretty quick. But we're going to go faster because this is going to take, you know, 214 days to get there, and we have more delta V than we know what to do with. So let's do that. We're going to leave this on, continue to collect 34 grams per hour. We're going to burn more than that, but we're going to continue to do that. We're going to actually change this to something different while we do the burn. Neon, no. Yeah, proton deuterium is actually... Well, no, we only have 3 days worth of deuterium. We're not going to do that. We have a lot of hydrogen, so I think it's safe to run the CNO cycle while we're burning the engine. So we're going to use nothing but hydrogen in this, but we're really not collecting enough deuterium for me to really justify using that while we're burning the engine. So I'm just going to turn this off. Just, you know, keep in mind 34 grams per second is what we're pulling in. Not a lot of radiators on this. This Muon Catalyzed Fusion Reactor doesn't produce nearly as, you know, it's pretty efficient. It's pretty good. So I've got, you know, about 3 gigawatts of power dissipation. We're not going to really be running at 3 gigawatts of power at any point in time, so we're good on this. Waste heat could be a little better. I could put bigger radiators on this. I could make this umbrella radiator bigger, honestly, is what I probably should have done. But honestly, it works. So let's go ahead. Point and fire. I'm just going to turn it on full blast. So where are we at? Fusion engine, 135 kilonewtons even. It's using about 300 megawatts, I think. Yeah, 353 megawatts. Magnetic scoop's using 420 megawatts. The reaction needs about 210 to maintain fusion. So about a gigawatt of power is what is necessary for this thing to fire the engine at full blast, keep the reactor going, run the scoop, and process what the scoop is taking in. And you're at about a gigawatt with a little bit of power to spare. Notice that we are just cooking along, and our delta V is not really changing because we're just collecting all that hydrogen. We are burning it a little bit as we turn it into solid hydrogen, but we've got so much that this is going to take forever to run out. We can run this for days, and that's what we do. So let's go back to the map view real quick. As you can see, we're ticking down the minutes. So if you look at the dawn encounter as it goes to 47, 46, 45, we're just shaving off minutes here as we fire the engine in real time. Let's make sure we're pointed directly at the thing. This is, it's honestly not the most efficient way to get to dawn, because I found that if you actually exit the Kerbal system like at an orbit around here, as if you were doing like just a moon transfer, and you actually are way out here and you burn and it loops you around, you can get a much easier encounter that doesn't require nearly as much delta V. But you can also point at the thing and fire until your engines give you a straight trajectory, and that's a thing. It's totally a thing. So we're still firing. We're gonna go ahead and time accelerate. Remember, a lot of these interstellar engines that are meant for interplanetary travel have warp thrust, so you can time warp and still get thrust, which makes them beyond awesome. Alright, so we're going to go ahead and time accelerate. Just keep an eye on, how much we can do this for a little while, but that drops down pretty quickly, 68 years. We're burning the years off by the minute, by the hour. Just keep an eye on our fuel up here. Plenty of fuel, but we don't want to run out of hydrogen completely. Because we need it to run our reactor. So when we get a little low, we're gonna switch that. There we go. Okay, now we have quite increased our speeds. We are now moving at, wow, 1,000,000 meters per second. So 1,000 kilometers per second is going to get us to dawn. Let's see, the encounter is going to occur in 92 days now. So our periapsis is now 115 days away. So we moved forward quite a bit. But if you can take a look over here, we're going to run into an issue in that we're going to have to brake at some point. Oh yeah, we're going to encounter oblivion on this trip. That's cool. 3 years from now, 3 years and 301 days, 4 hours, 4 minutes, we will escape dawn and encounter oblivion. At which point the vessel will be ripped apart. It's not going to survive that. Here's the thing, though. So we do that. We just fired our engines for a long time and achieved enormous velocity. And our delta V is like, what? Is that all you got? And we can switch this off to helium again. There's helium. Oh yeah, I need to turn off the refinery. Deactivate. Let's see, turn down to 4. Okay. Neon. Maybe, no, not neon. There we go. Charge that back up. And then what did I leave on? Scoop is the only thing that's still on. Okay. Alright, we should be good now. So we go into triple alpha. Yeah, tri-alpha should give us a little bit. Okay. Make sure that stabilizes. Process, and got a little bit of wiggle room. Bump the power up. Now, what I'm doing here is just kind of matching the power requirements of the magnetic scoop with how much, power I'm actually able to get out of the lower power fusion modes. 640 actually translates into, us getting about 437 with the thermal efficiency. We'd get better if I had better radiators, but yeah. So we're using helium. We're burning the helium. We're at about 11 grams per hour. We are collecting it at about 4.4 grams per hour at this rate. So let's see if we can find a good medium. So that's 10, 18, 14, 8. Yeah, see, so you're going to run into some issues in balancing, intake to outtake. So it's not really going to offset it a lot. But it is going to fill us back up on hydrogen. So let's just worry about that. Let's go 28 grams per hour of hydrogen collected. It's going to give us just under 10. So we're really only using 8 grams of helium instead of 18 grams of helium because we're offsetting it a little bit. But it's not quite infinite. It's not quite perpetual. It's not being replaced faster than it's being used while it's in use. We can turn things off and collect things. Just by hitting all the little tweaks and toggleables, you can rotate your usage and keep this thing going forever. It just it's not going to be an automatic process. A better craft would be able to just run the engine, the scoop, and the refrigerator with the refinery all at once and still achieve positive results. And a positive increase on all materials taken in, so that you're never going to run out of fuel. That's what you want, but that requires a ton of engineering. So that's the challenge. But this is how it works. You get this sucker out here. The faster you go, the more you're going to collect. So moving this quickly is why we're able to collect so much solar wind from a collection of stars this far away. It's because we're moving so fast. The thing is, if I were to turn around and point at Kerbal, I am fairly certain I would not collect anything at all. So let's go ahead and do that. I'm going to point away. Leave this thing running so you can see where the attenuation occurs. Look over here. Whoop, not there. Yeah, over here you can see we are going to lose connection very quickly. Here it goes. Well, not quite yet. Almost though. Oh, this is interesting. We are still collecting. I actually wouldn't have expected that. I would have expected us not to be collecting anything at this point. But yeah, we are. That's pretty neat. I stand corrected. Okay, so this far out, apparently we are still collecting from the home system as well, from Kerbal. So that's neat. Can't even see it. No idea where it is. I think it's that thing right there. Probably not, though. And yeah, we are still collecting, so that's actually really neat. That's good to know. Decent amount. Decent amount. Okay, well, in that case, I stand corrected. Maybe it's not a terrible idea to put a collector on both sides of your vessel. Like maybe if you build a vessel that has a magnetic scoop on the front and on the back, somehow, and doesn't get burned up by the Bussard engine firing, that would be a neat way to increase your production. So that's an idea. That's something you could do. Now here's the part though that makes this is why this is going to be kind of a short video, because unfortunately I don't have any mod installed that makes time acceleration better. So the best I can do is that. Oh, I just ran out of fuel. It switched to proton. We're good. So let's see here. Yeah, it's still going to take forever to get there. Dawn encounters 78, 77, 76, 75, 74, 73. So we could you know, just sit here and stare at this for a while. We could. We definitely could. It's going to take an awful long time to get there. But it's still going to get there faster than one might expect. It's still, you know, it's like a little over a year. You know, it's not the worst. Oh, we're actually... Can't tell if we're going to encounter some stuff here. Yeah, we're about halfway now, so let's get about... Yeah, let's stop here. Anybody else see that unknown object thing pop up? Did I, like, pass a meteor in deep space? I don't know what that was. Was that a comet? That space debris? Did something fall off? I can't really tell. I should have put lights on this thing. Okay. Let's get a refinery window back up. Oh, yeah. 163 milligrams. That's actually kind of odd. Why are we getting less now? Sphere, density, relative solar wind speed. I guess, maybe we were collecting, like, solar wind that was, like, colliding on the heliosphere of Kerbal and bouncing back, and that's why we were getting so much, and now there's not... we're too far between both stars. I don't actually know that much about it. Maybe we were collecting more because we were at a better angle to receive solar wind from these. There's like 4 stars over here. And then Aeon and Barrier are kind of hard to see right now. Let's see if I can... Yeah. Ah, see, here we go. This is why. Okay. So, previously up to this point, we were at a pretty good angle where we were receiving solar wind from all of these. Now our view is a little attenuated, and it kind of puts these guys a little off. So I'm going to try something here real quick, and I'm going to point a barrier and see if it does anything. No? Does not appear to change things. Okay. That's okay. So yeah, definitely more science and experimentation need to be done. I will be the first to admit I don't fully understand all the science behind the magnetic scoop. Just using it in the game, I am learning so much about it, and definitely going to need to read up on some Wikipedia stuff to get some more information on it. But basically, it's really versatile, really useful. Its main purpose, obviously, is to couple with the Muon Catalyzed Fusion Reactor and the Bussard engine to get you that milestone of infinite thrust. It's possible. It's definitely possible. I hope, if you take a look at this and you just kind of, see what the readings are here and what we're doing, what happens here. I really hope that is going to let you figure this out, and then you can show me you got infinite thrust, because it's totally possible. And even without infinite thrust, this thing will get to another planet, and there's plenty of delta V to slow down when we get there. I know it looks like we're not going to have a lot, but you're going to have some options. It's just going to be super ideal. What I'm honestly thinking I'm going to do is start, incremental slowing down, using up all my fuel, then point at dawn, like when I get close to it, to refuel, and then point directly away from it when I get past it, and then I'm going to slow down. And if I don't slow down quite enough, I still have Oblivion here to provide me with more solar wind and thus fuel to slow down. And then I can do a slingshot over into Traverse, where I actually have the planets loaded, because I didn't load any of the Dawn systems. I don't have like the most powerful computer, so I actually loaded the traverse system and the visuals, and then incrementally deleted planets until my computer didn't crash when I loaded the game. And now it's stable. So it just took me deleting about 10 planets, and there's still like 20 to visit in that system, so no worries there. Really don't know what else to show you on this particular part. I'm gonna go ahead and jump into the VAB real quick now, and I'm going to show you what it looks like, being built. But just take a good look at what these readings are right here, what we're dealing with, different fusion modes, and how much time you have when you're running those. So you want to make sure you don't run out of fuel on something you can't refuel. So the CNO cycle is pretty good. Obviously, proton fusion is great. Proton deuterium gives you tons of power, but your deuterium will run out quickly. And then like neon and whatnot is good if you actually have it. It doesn't actually look like it wants me to switch into neon. Quite possibly because I don't have the fuel for it. But that's okay. So we'll do that. I'm gonna go ahead and turn the refinery off. In the collector, so you can get the final like baseline reading. This does not have a pilot on it. It does have a crew cabin in there somewhere, and it's also got an AI unit. The AI is not on at the moment. Let's see if I can find where's iHal. It's in there somewhere. Just because this Bussard engine, actually, I didn't realize, it actually has a built-in antenna, and it's a pretty good one when you have all the upgrade techs. Looks like there's 8 there. So where's the antenna range? There it is. Antenna rating is 40T, so 40 terameters is plenty to connect between Kerbal and a neighboring star system. No problems there. It's not a relay, so you will need a relay if you want to do that, but as far as control, probe control, that sort of thing, the engine here and a few other ones act as antennas as well. And why shouldn't they? Because they use a lot of magnets and coils and bell shapes. I mean, it's an antenna as well as an engine. No problems there. Anyway, let's jump into the VAB for the final part here, and I will show you. I'm going to show you just what this thing looks like with the lights on. And then after we finish that, the next video that I'm going to make is going to be on the Aerospike Z-Pinch and other atmospheric burning type, interstellar type, engines and things, to show you some options you have for landers and that sort of thing. So we're going to get into that because I love me some landers. Landers are fun. And actually, I think I built this in the spaceplane hangar and not the VAB, so let's go in the spaceplane hangar. And again, I apologize for the long loading screens here. I'm going to get good at this video editing stuff. I'm using OBS Studio now. So it's free, open source. It's for Windows, Linux, and Mac. And it works. And there's a lot of options you have in there with it. I'm going to explore those as well and really get into that. Oh, and while I'm in here, let's first let me find the... there we go. While I'm in here, I want to let you know, KSP filter extensions is actually really, really freaking cool. If you want to find something, it actually lets you sort things, logically. I've actually had it installed since the beginning, but I haven't used it in my videos just because I tend to just kind of click where I know I've seen something before, and then I get lost and whatever. But if you want to find something like the Aerospike Z-Pinch engine, you can find it under all parts and aero parts, because it is an aero part, as well as any other thing with the lifting surface, control surface, air intake, that sort of thing. You're going to find it there. Cargo base, that sort of thing. Fuel tanks, tech level. You have a lot of options here, so be sure to utilize that, and I do apologize for not making that more known there in other previous videos. Alright, so this is this crazy contraption right here. And as I said before, it's super simple. Bussard engine. You gotta, like, it has a weird way of connecting, so a lot of people take a look at this and they're like, where's the connection? That's weird. So you don't have to use it as your root part. I did just because I did. But you take any old thing and you just kind of move it to that point, and that's its connection right there. So no problem. It just sticks inside the reactor because of the type of part that it is and what it's meant to do. It's just representing, like, this. There's more to this than just the bell sticking out the end. There's actually, a miniature fusion thing going on here, which, requires other things to make function. Okay. Big giant truss to separate things out so I can put the big giant radiator on. I scaled the refrigerator unit up to 375 so I can get a slightly higher yield. Obviously requires a little more power, but that's okay because I scaled the fusion reactor up to 3.1. That's an odd number, right? I did this because I was kind of trying to fine-tune it to not be too big, but still provide enough power to run all the systems when I needed it to run them. So this is kind of where I put it, based on my vessel. Your vessel, unless it's identical to this one, might want a different value. Bunch of these cryogenic tanks with the decoupler removed, since I'm not going to remove them. They're going to stay there. And then underneath the radiator is the crew cabin. Now, I definitely have to apologize here. I forgot that the Alcor capsule is not part of the stock game. I've been using it for so long, along with raster prop monitor and all the asset parts, that I can't really imagine playing my games without them. So I forgot completely that this is not a stock part, and so I uploaded a craft to the Steam Workshop that had this capsule as the command capsule, which obviously people that don't have that mod and connected mods installed aren't going to be able to do. So I really apologize for that. But definitely check it out. It still works in this game, and it's great for giving you that feel, because the inside is just so cool. The IVA is just wicked cool. And then we've got our magnetic scoop right here, 2.5 meters, and yeah, that's little control arms. Super simple vessel, super duper simple. 74.6 tons, but only 19 parts, and we've got about 14.8 gigawatts there of dissipation for a 7.63 gigawatt production. And as you saw, even that runs a little hot. So different vessels are going to have different success with that. Experiment, do those sorts of things. Trusty capacitor, I'm pretty much going to have these on all my vessels because I like them. They work. They're just super useful for those, like, when we were running out of power for fusion, that capacitor is why the vessel didn't just completely stop. Just to let you know, that capacitor is why I was able to do those silly things. Trust me. But yeah, check it out. Make one, try one, teach one, and then I'm gonna go ahead and get started on some lander type videos using engines, interstellar engines that can be used in atmospheres. Yeah. All right. Have fun, and I'll see you guys next time. Peace.